Hey, what's up guys? Welcome back to another video in the Java series. In this episode, I'm going to show you how to do Java 16 records. Alright, I'm back. It's been a couple months. I've been busy with school, but thanks to everyone who stuck by me and subscribed while I was gone, and I'm glad for all the support that you guys have given me. I'll try to respond to all of the comments that y'all left while I was gone, like I usually do, and just thank you for your support. So, while I was gone, Java 16 came out. Java 16 is the release before Java 17 because that's how numbers work, and Java 17 is going to be the latest LTS, so long-term support version of Java. So that's going to be like a big milestone for Java, and that's not really too relevant. But the things that Java 16 brought are pretty cool. They brought a few things. Some of them are like just optimizations, of course, small additions that we wouldn't really need to know about. But some of the biggest features are things like Java records, which are essentially classes that are meant to be immutable, and they're automatically generated by the compiler. And I'll be showing you how to do those. And there's some other stuff like text blocks, which may have been Java 15 or 16, that I'll be showing as well. Not this episode, but the next episode. So anyway, let's get started here. So first of all, what are records? Records are essentially a class in Java that is immutable. So, immutable. This means that it cannot be modified once it has been created. So, something that is modifiable would be mutable. So, let's go ahead and create our first record. Let's see how we can do it. So, if you go to our package and do new Java class, as you can see, there's a new record option here. So, we can select that and then give it a name. So, we're going to call our record bank account. And as you can see, the syntax is a little familiar. It just says public record bank account, and then we have this little parameter list here. So it's a little different. This parameter list is actually going to be the members of the class that you're creating, or that Java is creating for you. And so you're just going to provide the type and the name of the variables or the members that you want to exist in that class, and then it'll be compiled, generated and compiled for you. So let's say that our bank account, what are some things that we want to have inside of our bank account? What's a reasonable thing that we should have inside of a bank account, or information that we should store? I would say a owner name, so the name of the person who owns the account, and then also a balance. So this by itself is actually really all you need. It's just a simple class, and you just provide the name, and then you specify what the members of the class are, and then everything will be generated for it. So what do I mean by everything? So when this is going to be created, as the program is being compiled, it's going to come with obviously the members themselves. They're going to be private final, so encapsulated within the class, and then they're going to have accessors, so getter methods. So that's good too. So you can access the values since they're encapsulated, and then also you're going to have the other standard methods that you might find within a Java bean. So you can have a toString method, a equals method. That's actually useful. It's like generated and coded for you essentially, like you would usually do with IntelliJ. And then there's also a hash code method, which is useful for the equals method and serialization and stuff like that, and hashing. And yeah, so it's just a simple Java bean, except that it's immutable. So it doesn't have any setters generated. It's only accessors. So let's go ahead and see how we can use this. So we created the class, or record as you might want to call it. And then now we can use it just as we would a normal class or normal object that we would instantiate. So bank account 1 is equal to new bank account. So now we provide, as you can see, a default constructor has been generated here. So we can provide the owner and the balance to create this bank account with. So we're going to say Bob, and then Bob is a balance of 12,000 or 1,200.5. And then let's see what we have now with that. So account 1 dot, and then we have owner. So as I told you a second ago, this record will generate getters or accessors for this object here, but they're not gonna be named get owner or get balance or something like that. A lot of people have complained about that, or at least noticed that, but that's just how it is. So you're gonna have owner, you're gonna have balance, so the names are directly accessible, or the values are accessible through the accessor methods that are generated by the compiler. So let's say that we want to print out some information here. We can do sout the account owned by account1 dot owner has, and then the balance dollars. All right, so let's run this and see what that prints out. And there we go. The account owned by Bob has $1,200.5. So it's a simple thing. It's just simply a record is simply, again, just a class that's immutable, and the actual details and implementation of the class is generated by the compiler for you. But if you want to provide your own stuff, like your own methods, you can actually do that. You can do static methods, or you can do regular methods. So let's say that we want a method to drain the bank account, or actually let's do a deposit method. That'll make more sense. So if we want to do a deposit method, we can do, as we would normally do, we can do public void, or we'll do double for the new balance. So public double deposit. And so we provide the balance, the amount that we want to add, amount to add. And then, of course, the implementation here. So how can we access the balance variable that this record is creating inside of itself, and then use it inside of our deposit method? We can just do it the same way we would normally do. So we can do this dot balance is equal to this dot balance plus amount to add, except that we get an error here. It says cannot assign a value to a final variable balance. This is, of course, because you cannot forget that it's an immutable class. It cannot be changed in any way. It's meant to stay static. So instead we'll do something like public void report. And so inside of report, we'll just do what we did out here. Just copy that. The account owned by owner, or this dot owner to be more precise, has this dot balance dollars. There we go. So now inside of, or outside of that, we can do account1 dot report. Okay, pretty simple stuff. So you may be wondering, why the heck would I need to have a record? Like, what's the use cases for it? So one of the most common use cases that I'm seeing, according to like what I've read, the research that I've done, is a lot of the time it's useful for data transfers. Obviously this is a new thing, but in terms of what you could use it for is like data transferring and stuff like that. So let's say that you're accessing a database, so you're pulling from an SQL database and pulling the information into an object model. You can put that into a record because the data is usually only being transferred, it's not being modified. So you're going to put that into a immutable variable or object, and then you can do whatever you want with it. You can read from it and stuff like that. And then let's say that you're writing to a database, you could create a new instance of whatever record class you have created, and then put stuff in the constructors, and then you could write it to a database or whatever data source that you're working with. For example, a file, other types of databases, stuff like that, any type of database. So generally speaking, it's useful for situations where you know for a fact you're going to need a series of immutable variables, and you can just use those records as those immutable variables. There's not too much more to that. And another use case is actually for returning multiple variables in a method. That's actually an interesting topic. So usually whenever you return from a method, you can only return one variable at a time, or null or something like that. But with this, or you can encapsulate it into another object, of course. But with a record, you can also encapsulate into an object, except that it's an immutable object, so it makes a little more sense in terms of a design pattern for returning multiple things. It's only being returned and then copied. It's not actually being edited. So what you could do is, if you have a method and you want to return multiple variables from that method, you can just make a record, or instantiate a record on the fly, and then return that from the method that you're working with. So what I'll do is actually make a video on that. I'll demonstrate that for you. If you want to see that, let me know. It's a pretty cool process, and I'll also show you how to do generics with records too. So let's talk a little bit about what records are behind the scenes. I've done a little bit. I've told you that they are automatically generated when you compile the program and the source code is generated for the record. But also, these records are essentially final classes. But that's what makes them immutable. The classes are final. And also, they extend implicitly the record class. So if we go ahead and control Q record here, you can see that it extends record itself. Of course, this may be a little hard to read just because it's like it's white for some reason. It says this is the common base class of all Java language record classes, and you can read into that if you want to, but so hopefully you know this, a regular class that you would create extends the object class, but a record here extends the record class. And of course the record class extends the object class, so it's still an object at the end of the day. So a record cannot extend or implement any classes or interfaces, by the way. That's just part of the design for it. And like I said a second ago, you can add non-static and static members, or rather methods. So if you want to make this a static method, you can do that if you want to. So that's something you can do. And then I think you can add static variables. So private Bob, private int Bob. You can't do that, but you can do private static int Bob, and that'll work just fine. So that's cool. So this is where it gets a little tricky, but also interesting. The constructor generated by this bank account record is called the canonical constructor. I think I'm saying that correctly. It's the canonical constructor. And then if you want to create a custom constructor or add constructors onto your class, as you might do for a regular class, you can do that as well. So if I want to do that, I can do public bank account, and then whatever I want to provide as the parameter, so I'll say the owner. And so if you look closely here, it says non-canonical record constructor must delegate to another constructor. So of course we have the default canonical constructor. Did I say instructor? I mean constructor. So what we have to do is then call that or invoke it and pass in the values for it, since it's not being invoked when you call this. So this one has to delegate to this one here. So to do that, you can just do this and then pass in the two things that I want, the owner and the balance, because those are the two members of our canonical constructor, not instructor. And so we can pass in the owner provided to this constructor here, and then we can also just pass in a default value for the balance, so 0.0. And now we can go back to, well, first of all, this is, erroring because this is a static method now, so you can't really call the non-static members, but so we'll just get rid of this. Simple Java. So now we can go back to here, and instead of doing new bank account and then using the default canonical constructor, we can call upon the one that we just created by just providing one parameter. And there we go. So Bob, and then what that is going to do, as you saw, it should initialize it with a balance of $0. So the account owned by Bob has $0. Good. Very simple. And so that's how you can create new explicit constructors, but there's also something called a compact constructor. So this is essentially us providing our own implementation for the canonical constructor. So as you know, sometimes when you create your own classes, you want to create some other implementation inside that constructor besides initializing the variables. So how can we do that if it's being automatically generated, right? It's not going to include what we want it to include. So to do that, we can include we can do a compact constructor, which is a way of putting some default implementation code before the values are set by the canonical constructor. So it's going to be placed in the beginning of the canonical constructor. And I really hope I'm saying that correctly, by the way. That would be embarrassing if I'm not. So to create a compact constructor, you can do public, the constructor name or the record name, and then you just put brackets without any parameter list. So that will match it to the canonical constructor. And inside of this, you just put the logic that you want to appear headed in the beginning of the canonical constructor. So if we want to do some logic like outputting something, we can do that. So bank account is being created. But we can also check some values. So let's say that, so this is the canonical constructor, right? So we know that these two values are going to be passed in every time. So what we can do is check to see if there's something wrong with these two values. We can check them in whatever way that we want to. So we can say that if the balance, the default balance is going to be, or the initial balance rather, if it's negative, so if it's less than 0, then what we can do is reject the creation of this. We can throw an error essentially by rejecting the creation. We can throw an exception and reject the creation of this new object by doing throw new illegal argument exception, because it doesn't pass the requirements we want it to for our constructor here. So we can do throw new illegal argument exception, and then we can give it a reason. We can say balance cannot be negative. So that's a simple use case for these types of compact constructors. You just put whatever logic you want. If for some reason a valid is not correct, you can throw an exception for that, or you can throw some other exception if you need to, of course, if the situation permits. So yeah, let's test this one out. So what's the problem? Oh yeah, of course, this is not correct. We removed the other constructor that we had, so that doesn't work anymore. So now let's provide a negative thingy and see if it throws the exception like we want it to. There we go. So it says bank account is being created, of course, because this is running first. And then it says exception in thread main java.lang.illegal argument exception, balance cannot be negative at me.codysimpson.bankaccount. And yeah, pretty simple, right? So that's how you create what's called a compact constructor. Okie dokie, so one thing I didn't show you is how to use the methods provided by the bank account record, besides the accessor methods. So I did tell you that the record automatically generates a toString equals and hashcode method. So let me demonstrate how you can use those. First of all, this is not working just because it is, oh, I deleted it. That makes sense. Okay, so let's say that we have another bank account. So bank account 2 is equal to new bank account, and Joe has $10 or $19 in his bank account. If we want to see if those two bank accounts are equal, we can do if account 1 dot equals account 2. And if you know anything about the difference between the equals method and the equals operator, then you know that the equals method just checks to see if the variables inside of the objects are equal to each other, rather than if they're the same objects in the memory. So now if you print out, let's say we can say they are equal. There you go. And then otherwise they are not equal. Alright, so let's run this now and see what we get. They are not equal. Alright, cool. So that's how you use the equals method. Of course, you can do it the other way too. You can do account 2 dot equals account 1. It doesn't matter the direction of it. So to see if the equals method actually works, I made them the same. So now let's run this, and it should say they are equal now. There we go. So it says they are equal. Good. So that's that. Let me also show you how to use the toString method. So let's say that we want to print out in one of these objects here. So account 1, we can simply print out account 1 just by putting it there. So since the toString method is overridden, it'll say they are not equal first, and then it'll say account 1 bank account, and then the information of the object. And if you don't override the toString method in a normal class, then you would not get this. You would just get a something like a memory address or something like that. You wouldn't actually get this information here. So as you can see, even though we didn't override it ourselves, the compiler overrid it for us, and we got this here. So we got this functionality just by making it a record. So that's one benefit of records as well. It does all that for you. You don't have to do it yourself. And that's actually pretty much all I want to show you. That's how you can create a simple record. All you got to do is, let's get rid of all this here. All you got to do is just do public record bank account, and then provide the members inside of the parentheses that you want to exist within that record that is going to be generated for you, or a final class as you might call it. So just don't forget that a record is essentially a immutable class created by the Java language. And they're going to help you with a few things like working between data sources and other various things that you want to use them for. And there's a few other design patterns like for streams and stuff like that. You can use records for those. And some other videos, like I said, I'll show you how to do those things like returning multiple values from methods, generic records, using them with streams perhaps, other stuff like that. So I plan on using these much more in the future. And also there's pattern matching with records too, which is something I'll be showing. So stay tuned for that. Anyway, that's pretty much it. I hope you enjoyed this episode. I hope you found it informative. Yeah, so let me know if you liked it. If you did not like it, let me know why, how I can improve. If you want to see more, hit that subscribe button. If you like the video, hit the like button. Make sure to check the description below for the code for this episode so you can come back to it at any time you want to review it or anything like that. I'll mark it up with comments and all that information for you so you don't have to rewatch the episode. Unless you want to give me your review, of course, that'll be nice. And I will also leave a bunch of articles in the description below, so make sure to check that out. And you can look at some other information that is provided by those articles that may be something I didn't provide in the video, but I tried to read all of these articles and then encapsulate it into one video, so hopefully I did a good job for you guys. But if you want more information, then check out those articles below. And one final thing is, actually two things. First, if you want to become a member, you can click the join button below this video, and you can join this channel as a member for as low as 99 cents a month, and you can cancel at any time. You get some cool perks like early access to all of my new videos, and also you get a new rank on my Discord server. And besides that, you also get my love. So do that if you want to. If you want to join my Discord server, there's a link for that in the description below. So make sure to join that. We have a nice community where you can get help and all that fun stuff. So make sure to join that. Anyway, that's pretty much it. Thanks for watching. Leave a like if you like this video. Subscribe if you want to see more. And peace.